This is Christopher Boucher, and I'm going to explain how to create a relative frequency distribution. If you have not seen the first video, which is the frequency distribution, I recommend you go back and take a look at it. So what I do in this video is I start off at the frequency distribution outcome of the last video, and it's because with each part that we add, so we start off with the frequency distribution and we fill in these numbers. And then when we go on to the relative frequency distribution, we add the column on the right. And then next we're going to do a relative cumulative frequency distribution, and we're going to add one more column. So if you haven't seen the first one, please go back and take a look at it. It's just called frequency distribution, and that's what it is. So with this one, we're going to be making a relative frequency distribution. What a relative frequency distribution is that what we do is we have the frequency of each observed data value or value, and we have the total, which is 16 in this case. So it's the total of the frequencies, not the total of any of this. What we do is we go and we take a look at the frequency and divide it by the total, and that gives us the relative value, and that's all that we do. So for the first one, what we're going to do is we're going to have 3, and we're going to divide it by 16. So we just click this. And I have some notes here so that I don't have to calculate on the fly. And so for 3 sixteenths, it is 0.1875. What's nice about these is when, for all of the 3's, in this case there's only one 3, but for all of the 2's they're all going to be the same. So for 2 divided by 16, or 2 sixteenths, it'll be 0.125. And then so what we can do is we can just do this. So that saves us some time. And then for 4, we need to do the calculation, which would be 4 sixteenths. And 4 sixteenths is, you could reduce it down to 1/4, right? So we end up with 0.25. And then for 1, we have 1 sixteenths. Technically, you could leave them as fractions if you wanted to. These are nice kind of round numbers in that they don't go out forever. If you need to kind of figure out where you stop with your precision on the decimals, I would go out to 4 decimal places. And it's just a good habit. I don't like to round. People round all the time, but I usually go out to 4 decimal places, and it's pretty good. Until you get into compounding numbers and things like that, 4 decimal places usually works well. Okay, so for 1 sixteenths, it's 0.0625. My handwriting's not good, so I have to be careful, especially when we're making videos. Otherwise, it's hard to tell what I'm doing. So, because these don't have kind of go on forever type of things, where in elementary school you'd learn, they'd say put a line over it or round or something like that. With this actually equals 1, which is very nice. But if you have these numbers where you have to cut off the precision and just go out to 4 decimal places, this isn't going to equal 1 always. And so you just have to remember it should be very close. It should not be over 1. If it's over 1, then you made an error somewhere in here. If it equals 1, that's great. A little bit under 1, usually like 0.99 something 8, that's fine. You're close enough. It's just some precision you're lacking. And that's it. So now we've done the frequency distribution video, the relative frequency distribution video, and next up is the a relative cumulative frequency distribution video. You would think it'd be frequency relative cumulative, but that's not what they call it. They call it, the next one they call relative cumulative frequency distribution. Thanks.